Hey guys. Alright, from 4.3 we're going to talk about the remainder theorem. And really we've already talked about it, we just haven't called it the remainder theorem. And this is the polynomial that we used for the long division examples. For instance, we looked at dividing the polynomial by the factors x plus 2 and x plus 1 to see if it would go in there evenly or have a remainder. And here's where we did it with x plus 2, and we ended up with 0, so that was a factor. And in here we did it with x plus 1. We had a remainder of 4. Where the remainder theorem comes in, it doesn't matter if you get a 0 or a 4. What it is that uh, outside of a 0 you have there's a little bit more to it, but I already covered it in what we did. Okay, and we're gonna talk about it now. Pull that example back up. See, what we did was that we looked at that and we found that x plus 2 gave us a remainder of 0, and x plus 1 was not a factor, and we had a remainder of 4. One key point to point out: whatever your remainder is from your division, that is the value at that x value. See right here, this says x plus 2, and that's what I'm looking at. This one up here, all of this deals with x plus 2, and all of this deals with x plus 1. So if I look at x plus 2 equals 0, what is the value of x? Well, x equals a negative 2. And if I look at x plus 1 equal to 0, the value of x is actually a negative 1. So that's why I'm plugging in a negative 2 here and a negative 1 here. And whenever I plug in that negative 2 and I actually solve, I evaluate the function at f of a negative 2, I get the value of 0. That was its remainder from the division. Whenever I plug in x equals a negative 1 for the function, so I plug in a negative 1, so f of negative 1 of the given polynomial gives me a value of 4. That was the remainder for that long division. Function values are the same as the remainders. Function values are the same as the remainders. That is a very critical point in what we're looking at. But with the remainder theorem, I kind of already covered it. I showed you. And right here, this is what I've showed you. So I'm going to go through this and then reiteration of basic arithmetic long division, and to show you what we'd already seen. If a number c is substituted for x in the polynomial f of x or p of x, doesn't matter what you call it, then the result f of c is the remainder that would be obtained by dividing f of x by x minus c. And see how we did that? If I know that this is my x value, if I know, let's say, x equals 2, well, let's set it equal to 0. So move x over there, or the 2 over there with x, that becomes x minus 2 equals 0. That's where I get my x minus c. Okay? That is the c value right here. Then this is what we know. That if we take the divisor, x minus c, and multiply it by the quotient, the answer, and then add the remainder, then f of c, that value of x that I saw for, is equal to the remainder. The value of the function is the remainder. And we looked at that over here. I said if I were to take what I'm dividing by, the divisor, x plus 1, and multiply it by my answer, or what we call the quotient in a division problem, this is the quotient, if I multiply those two together and then add the remainder, then I will get the original polynomial that was the dividend. And that's what this theorem is saying. If I take the divisor, x minus c, and multiply it by my answer, the quotient, and add to it the remainder, then f of c will equal r. And to reiterate that point, f of c equals r. This is what I have here. F of c equals r. My c value is a negative 2, so x plus 2, and my r value, which was 0, the remainder was 0. This is what we've shown. Yes, same here. If I have that as f of c, it will equal the remainder. Well, my x plus 1, right, write that out over here, x plus 1, that was my initial divisor, so what does x equal? I want to find that, I just set it equal to 0, so x equals a negative 1, that's why I have a negative 1 in here. That is c, x plus c. This is my remainder. From that problem, we had a remainder of 4. That is actually my function value. And to bring it all home again, this is the example that we had in the prior lesson. My divisor, my divisor, my quotient, my quotient. So I have 8 times 2. 8 times 2 is 16, correct? 16 plus the remainder, this was the remainder that was left over, so the remainder gives me 22. Okay guys, that is the remainder theorem. Big takeaway though is to understand that the value that I plug into that function, what I get for it, would be the remainder if that was the divisor. Okay guys, continue to watch your publisher's videos, please. Structure and critically think about your homework. Apply what you're learning. It scaffolds. What we've learned in one lesson leads into the next. So if you realize, okay, I don't know that as well, go back and work some of those other homework problems. And as always, good luck on your homework.